All right. Boys and girls, we're going to talk today about stem and leaf plots. And what we're going to do is we're first going to go through the lesson and we're going to review what a stem and leaf plot is. And then we will make some stem and leaf plots together because I think when you're making something, it helps you to understand it a little bit better. So a stem and leaf plot shows data using place value. So you might have a plant, right, that has a stem and it might have several leaves off of it. So the stem is going to be the number that's in the tens place. The leaves, you're going to have several leaves attached to each stem. So these are grades that 10 students scored on a math assignment. So we have 71, 58, 56, 69, 42, 72, 64, 56, 44, 88. So this must have been a really hard math assignment. Now, the first step when you're making a stem and leaf plot is to put the numbers in order from least to greatest. So you can see this is the lowest score, 42%, and this is the highest score, 88%. Now what we're going to do is we're going to put the digits that are in the tens place go in the stem column. So we have 40. So we're putting a 4. That represents 40. We have 50. That represents 50 right there, the 5. We have 60. That represents, this 6 represents 60. This 7 represents 70. And this 8 represents 80. Now, look, we have two numbers. We have 42 and 44. So this represents 42 and 44. These are the numbers that are in the ones place. We have 56, 56, 58. This represents 56, 56, and 58. Now we have 64 and 69. This represents 64 and 69. This represents 71 and 72. This represents 71 and 72. And this represents 88, okay? So the data ranges from 42 to 88, so we're going to list the tens 4 through 8 as stems, which is what we just did. Now, for the grades 42 and 44, the numbers in the ones place are 2 and 4. Write 2 and 4 side by side in the leaves column to represent the ones place for both 42 and 44. Order the numbers in the leaves column from least to greatest. So see how this goes 56, 56, 58? That's why you put them in order from least to greatest so that your chart is really organized. And so it goes from least to greatest. And also so you go 40, 50, 60, 70, 80 instead of 80, 60, 40, 30, like all messed up. You want it to be in order from least to greatest this way and least to greatest this way. Okay? Now, once you have a stem and leaf chart, you can figure out the median. So we're going to use our stem and leaf plot in the book to figure out the median. So how do we find the median? Well, we count the leaves. Since there are 10 leaves, the set of data has two middle numbers, 68 and 64, right? Oh, 58, sorry, 58 and 64. The mean of 58 and 64 is the median, so we're going to add these together, right? 58 plus 64 divided by 2, so that's going to be 122 divided by 2, and so our median is 61. Now we're going to find the mode. Which one appears most often? Well, 56 does. There's two of them, right? And you can tell this by looking at this stem and leaf plot, because look, I have 56 and 56 right here, right? I have two sixes, so that's 56 and 56. Now we're going to find the range. The range, we find the greatest number and subtract the smallest number of data from that. And that will give us the range, which is 46. An outlier is any number in the data that is much farther away than the largest group of data. The outlier of this set is 88. So 88 is a lot farther away from all the other numbers, right? These are only 2 apart. This is roughly about 10, 12 apart, 2 apart, 4, 5, 6 apart, 5 apart, and these are really close together, and then all of a sudden there's 88, which is way far apart. So 88 would be the outlier. It is easier to find the mean directly from the set of data than from the stem and leaf plot. Okay, so what we're going to do next is we're going to make a stem and leaf plot once the lights go back on. See if I wave a piece of paper, if that will make it work. There we go. So we're going to draw this stem and leaf plot and kind of talk about it. And then we're going to do the problems on here. And then we also have some baby elephants in zoos. And we're going to make a stem and leaf plot for the baby elephants. Okay? All right. So our first stem and leaf plot that we're working on is weights of crates of potatoes at a supermarket. That's not very exciting, but it is what it is. So we're going to make it right here. I'm going to make it in these two spaces. Here's this. Here's this. And here's this. Now the cool part about a stem and leaf plot is it's just going to need a title. It's going to need a thing that says stem and leaf. Right, so if we start out like this, and we say this is weight of crates, and then we say that this is the stem, and these are the leaves, and then we have 2, 3, 4, 5, 6. So we need 5 more little lines. We're going to go 1, 2, 3, 4, 5. I like to kind of sketch it in first so it's not too messy. Too messy. It's kind of messy. So we have our first piece of data is 25. Then we have 30. We have 34. And then 34. And then 37. Then we have 48. Then we have 52. And we have 58. And we have 69. And over here, this is telling us that we have 215. Remember, these are each worth, this is not worth 2, 3, 4, 5, 6. It's worth 20 plus 30 is 50 plus 40 is 90 plus 50 plus 60, right? So it's going to add up to 215. And then over here, we have 25 ones, right? That's what that little piece of information means at the bottom, right? So this kind of reminds you that this is worth 20, 30, 40, 50, 60, because it's worth 215 all total. Okay? Let's answer some questions about our stem and leaf plot, and we'll try to do most of it on this side. So we have problem number 1, question number 1. Question number 1 says, for the number 58, 5 is in the column and 8 is in the column. Well, 5 is in the stem column and 8 is in the leaves column. The stem 3 has how many leaves? Well, it looks to me like it has 4 leaves, right? Because it has 4 digits. The weight that appears most often is pounds. So let's see what appears most often. I see double 4 over here. I see 2 8s, but one's 48 and one's 58. So that's not going to be the mode. But this is going to represent 34 and 34. So I think the mode is 34. Okay, let's look at number 4. Number 4 says the median of the set of data is blank pounds. Okay, so we're going to find the median. We have 25, and we can use a highlighter to do this. I think we can. So if we go, remember median, you put them in order from least to greatest. This is in order from least to greatest. This would be my first number, 25. That would cancel out 69. Remember, because we go in partners. Then I have 30, and then I have 58. Then I have 34, and then I have 52, and then I have 34, and then I have 48. So my median is going to be 37. Okay? Makes sense so far? Let's look at number 5. I'm going to come way over here. Number 5 says the greatest weight of a crate of potatoes is, well, which number is the largest? 69, right? 69 pounds. By the way, when I taught 3rd grade, we could never figure out why the abbreviation for pounds was LBS. So one of my students, a little 3rd grader, looked it up. And so if you want to look it up and find out why the word POUNDS is abbreviated LBS, you can find the secret answer. It's a really cool answer why it's LBS. Number 6, the least weight of a crate of potatoes. So the smallest one, because the stem and leaf is in least to greatest, we know that the smallest one's going to be 25 pounds. Okay, let's do 7. Number 7, the difference between the least and the greatest weight of a crate of potatoes is blank pounds. So the greatest is 69. The least, we said, is 25. So the difference is 44 pounds. Right? So the range is 44 pounds. All right, now we have to find the total weight of all the potatoes. Ay, caramba. That's going to be a lot. I'm going to chunk the weights, okay? So I'm going to just read them off the stem and leaf, and I'm going to chunk them. So we're going to start with 25 plus 30. We're going to add that to 34 plus 34 plus 37 plus 48 plus 52 plus 58 plus 69. Ay, ay, ay. So all I did was I just went through and I read these 25 plus 30 plus 34 plus 34 plus 37 plus 48 plus 52 plus 58 plus 69, right? Now I'm going to add the chunks together. This first chunk, I'm going to go up here. This first chunk, 25 plus 30 is 55. This next chunk is 68. This next chunk is 5, regroup the 1, is 85. This next chunk is 8 plus 2 is 10. Regroup the 1 and we get 110. And then we have to add 69. So I'm going to go ahead and add this big row of numbers. I want to get close to 10. 5 plus 5 is 10. Plus 9 is 19. Plus 8 is 27. Regroup the 2. Let's see if I can get close to 10. 8 plus 2 is 10. Plus 5 is 15. That's 21. 22. 28. Regroup the 2. and I get 387 pounds. LBS. That's the total amount of pounds. Okay? Now we're going to make our own stem and leaf. We're going to do that. It's on page 209. Okay? And we're talking about masses of baby elephants born in 2 zoos. Okay? So we're going to have to make a stem and leaf plot to show each set of data. Okay? So we're going to have to make one for, let's see if we have to make it. I don't think we have to make 2 different charts. I think we're just worried about elephants, not about zoos. Or do we have to make 2 stem and leaves? Let's make 2, just in case. Okay, so I'm going to flip. And this is what it looks like in my math book, in case you don't have your math book. It says make stem and leaf plots to show each set of data. And it says plots, so we're probably making 2. Then complete the sentences. The table shows the masses of baby elephants born in 2 zoos in a year. Masses of baby elephants born in 2 zoos. That's an exciting title. Zoo A and Zoo B. So we're going to make a chart for Zoo A and Zoo B. We need, let's see, 5, 6, 7, 8, and 9 on this one. And we need 5, 6, 7, and 9. We don't need an 8 there. Okay? So let's make our 2 charts on the back side. I'm going to connect them together. So that's going to be my title. And then I'm going to chop them in half right here. So we're going to call this masses of baby elephants. And we're going to put this is Zoo A. And this is Zoo B. Okay? We had one needed one more than the other, right? Zoo A had more, like one more elephant. So Zoo A needs, I'm going to count them out, 5, 6, 7, 8, and 9. So I need 5 little blanks for here. So I'm going to go 1, 2, 3, 4, and I'm going to give myself 1 extra down here. And I don't think the other one needs that. And this one can just go right here. Bloop. This is not quite as neat as it could be. Shh, don't tell anyone. Okay, so right here is this. Oh, you know what? We should have written stem and leaf on here. Doggone it. Let's do that. Let's give it one more. Just to be super official here. So we're going to write so that we know what the stem is and what the leaves are. Oops. Hello. Hello, Karen. Come on. So this is going to say stem, leaf, leaves, stem, leaves. Okay. So in our first numbers, we had 50, then 60, then 70, then 80, then 90. 50, then 60, then 70, then 80, then 90, right? This is Zoo A. Zoo B, we had 50, 60, 70, and 90. 50, 60, 70, and 90. Okay, because Zoo B has one less elephant. Right? Like one less elephant was born. And they don't have any 80. There's no 80-pound elephant. Now, for our leaves on Zoo A, we're going to find the ones, we have to like look really carefully. We have only 150, so it's 56. We have two 60s, and they're both 62. Right? So this represents 62 and 62. We have two 70s. We have 76 and 78. So this represents 76 and 78. Then we have 188-pound elephant. And then we have 196-pound elephant. Okay? Now let's go down to Zoo B. We have only 152-pound elephant. We have 65, 65, 65. So we have 5, 5, 5, 65, 65, and 65. And then we have 74. And then we have 93. Okay? All right. Now here comes some questions. Dun, dun, dun. The mode of the masses of baby elephants born in Zoo B, right, is, and these are also kilograms. Sorry, we didn't put that on there. So let's look at number 1. Zoo B, we're looking for the mode. Obviously 65, 65, 65. So the mode is 65 kilograms is the mode, right? That makes sense because there's 3 65s, right? The mode of the masses of baby elephants born in Zoo is less. Yeah, it's less. It says the mode of the masses of baby elephants born in Zoo B, 65, 65, 65, is less than the mode of them. Whoops, I messed up. So this is A and then B, right? So the mode over here in Zoo A is 62, 62, and that's less than the mode in Zoo B, which is 65, 65, 65. The median mass of baby elephants born in Zoo B. So here's Zoo B. We're going to find the median. Let's use our trick. We go to the biggest number. Then we go to the smallest number. Then we go to the next biggest. Or next smallest, next biggest. And then these two, it's 65, right? So it's 65 kilograms. 4. Smells like burning wood. I hope the school's not on fire. I don't hear a smoke alarm. Somebody's burning, though. You can smell burning wood. The range of the masses of baby elephants in Zoo A. So remember, range is greatest to least. So in Zoo A, our greatest is 96. Our least is 56. When we subtract them, we get 40 kilograms. Right? Okay, our last question. The total mass of baby elephants born in Zoo is greater than the total mass of those born in Zoo So we have to add up all of the elephants. So let's add all the elephants in A. So we have 56, and remember, I'm going to do what I did before. I'm going to chunk them. 56 plus 62 plus 62 plus 76 plus 78 plus 88 plus 96. Okay, so that's Zoo A. This is zoo B. 52 plus 65 plus 65 plus 65 plus, did I get 3 65s? I did, plus 74 plus 93. So even though zoo B has less data, right, because there was one less elephant born, this is, and the less elephant born was 88, like in the 80s. We still have a lot of 65s here. Let's see if that does anything, or if this zoo B is less. So once we do this, we're adding this chunk. 6 plus 2 is 8. That's 118 plus 6 plus 2 is 8. 7 plus 6 is 13. Plus 16, regroup, 16 plus 96. And we might have to stack those. Let's look down here. We have 7, 117 plus 5 is 10, regroup, 13 plus, oh yeah, I think this is going to be bigger. And then 7 and 9 plus 7 is 16. Okay, so I'm stacking these up over here. This is going to be my little work area. 118, 138, 166, and 96. This looks like it's going to be more elephants, huh? 8 plus 8 is 16. 16 plus 6 is 22. 28. Regroup the 2. Again, remember we want 10, so 9 plus 1 is 10. Plus 6 is 16. 17, 18, 19. 20, 21. And this is 518 kilograms. Now let's do work area over here for zoo B. Zooby dooby doo. 7 plus 7 is 14. 6 plus 3 is 9. 10, 11. And this is 414. So zoo A, that extra elephant really added up. Right? Okay. We have some quick questions that I think we need to answer on 210. They don't really have to do with stem and leaf plots. It's just asking us about a craft fair, and it's asking us the range and the mode and the median. Okay? So we're just going to look at those really quickly. So we have, this table shows the number of crafts that a group of students made at a fair, number of crafts made. Here are all the students' names. And then here are the crafts that they made. They were busy little bees, especially Stella over here. She was killing it. So the range of the set of data, remember for range, we're finding greatest minus least. So the greatest, I think, is Stella here at 64. And the least is going to be 32, Jordan. So 64 minus 32. And that's 32 crafts. Okay, so the range is always the greatest minus the least. The mode of the set of data. So do you see any that are the same? I see 44 and 44. I don't see any others that are the same. So I think the mode is going to be 44 because there's 2 of them. Oops, lights out again. All right. Number 8 is the median. Now, this is going to be tricky because to find the median, you have to list the data in order from least to greatest. If you don't, it is impossible to find the middle number. So I'm going to start out by listing them. I start out with 32 is my smallest number. And then I go from 32, I have 38. And then I go in my 40s, I have 40. Then I have my two 44s. And then I have 47. And then I have no other 40s, I'm just looking. And then I have 51. And then I have 64. So this could have been a nice, they aren't telling us to make a stem and leaf. Well, I guess they are telling us we do have to make a stem and leaf plot because number 9 and 10 asks for stems and leaves. So we will do that right over here. We'll make a stem and leaf plot. Let's find the median first and let's double check that we got all of the data. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's looking good. You know, of course, that means we're not going to have a middle. Well, we do have a middle number. They're both the same, luckily. So our median is 44. That is lucky. Lucky ducky. Okay, let's make a stem and leaf plot really quickly. Right over here in the corner. I was thinking we wouldn't have to make one because it didn't tell us to, but now I can see that it really wants us to make one. And I'm going to make it really small. I need to have 8 lines. So I'm going to go like this. This is number of crafts made. This is going to be the stem. This is the leaves, right? And I need to have 8. So I'm going to cut this in half, which is and then I'm going to cut the halves in half. And then I'm going to cut those halves in half. Right? So if I cut those halves in half, I'm going to have 8. Oops, that one's a little schmidgy small. Okay, 1, 2, 3, 4, 5, 6, 7, 8. I gotta cut these in half. Geek. Fractions. Okay. Oh, you guys, I wasn't even thinking. We probably don't need all these lines because we have several that are doubled up, right? So we have 32. I wasn't even thinking. This is going to be 3. This is going to be 4. So I made some extra lines. So we have 32, 38, 40, 44, 44, 47, 51, 64. And then we have this shameful mess down here that like we shouldn't have even made. Sorry about that. How can we make that disappear? I could cut it and fold it, but you'd still see it. Okay, there are blank leaves for the place value of 3 tens. How many leaves are there for the place value of 3 tens? 2 leaves, right? And number 10 says there are blank leaves for the place value of 4 tens. Well, there's 1, 2, 3, 4. All right. So I feel like now you have an understanding of stem and leaf plots. They are a way to show place value. They are a way to show place value with tens and ones. They are also, I will warn you, something that parents never had to do when they were in school. So when your parent sees a stem and leaf plot, they probably aren't going to understand what that is or what you're doing. So they might try to help you with your homework and they might end up walking away more confused than they were before. So you can show them this video, hopefully, and they will understand what a stem and leaf plot is. All right, I will talk to you later. Thanks for joining me.